Okay, here we go. This is going to be a slightly different video to ones that I have done in the past. I've done a lot of topic-based videos now. I've done some videos on how to make best use of your calculator. I've done lots of different things. One thing that I thought that I haven't done, and I may have done a video on this, but I don't think I have, is what it says right there. How to start that question where you just don't know what to do. Okay. What I'm planning to do for this video is not go through any particular topics or go through any particular methods, but instead what I'm going to be doing is thinking about how do I start those questions. Okay, I've picked some questions at random for variety of different difficulties. Not looked too much into them, so you can get my kind of instinctive thought process on how do I deal with these questions where I might not know where to begin. Okay, because you will have studied a variety of different mathematical techniques at this point, and now it will just be a case of picking the right techniques, knowing when to use that particular technique. Okay, so let's have a look at our first question and see what it is we're going to think about along the way. So we've got a question here. This says that a diagram shows a cuboid with a cylinder cut out. The length of the cuboid is 27 centimeters. The volume of the cuboid is 2,187 centimeters cubed. And we're told that the diameter of the cylinder is the same as the length of each side of the square base. We want to know the volume of the cylinder correct to three significant figures. Now, area, volume, general shape related questions, I always start off by thinking, okay, what are my areas, volumes of those particular shapes? Okay, so off to one side, even if I'm not sure where to begin, I might go volumes. Okay, we know that the volume of a cuboid will be length times width times height. Okay, now we know that you can imagine if this was stood up, we've got the 27 would be how tall the shape would be. I'm going to call this the length and the width just for the sake of the square. It doesn't really make that much of a difference. I don't know the length and the width of the square. Okay, that is just some unknown measurement that is x. I don't know it. I've also got a cylinder, and a cylinder is pi r squared, circle, this area of a circle, times by the height. Okay, and again, we can say that that is our 27. Okay. Now, I've not really looked too much into this question, but I know that these are two things that I can use with this question. I know that the volume of the cuboid is 2,187. I know the length of the cuboid, of what I'm calling my height. So I know that x times by 27 is 2,187. Taking small steps from there, we can see that I'm going to have 27 times by x squared. And again, if you're not sure where to begin a question or what to do next, take the next small step that you can. Okay, I'm going to erase my pi r squared times h for the moment, just so I've got room to work in. I'm going to put it a little bit further down. I can figure out what x squared is by dividing by 27. X squared equals something. And then I can find out what x is by doing the square root of that thing. Okay? It's about taking small steps. and starting with a bit of information that you know what it would be, even if it is just a volume formula. Okay. Now we've said that x is the distance going all the way across this circle. What I need to know is my radius, which is going to be exactly half of that, because we're told that the diameter of the cylinder is the same as the length of each side of the square base. Okay, so it's then about taking the next small step. How do I go from my diameter to my radius? Well, we half it. Once I know what my radius is, plug things into the formula to work out the volume of your cylinder. And generally, I would say that area, volume problems like this are approachable by using those small steps. Start with a formula, start with a piece of information that you've been given. What is your next small step? What can you do next? Okay. Now, with slightly different problems will come slightly different strategies. Okay. Maybe you'll need to think of ways to represent a piece of information. If we're talking about ways that we represent information, this would be a good question to think about. Okay, so again, not going to look at it too much, but I'm just going to see what small steps can we take. A slimming club has 90 members, 57 members eat fish, 41 members eat meat, 15 members do not eat fish and do not eat meat. And a member is chosen at random. Find the probability that this member eats fish and meat. So, looking at this, what is going on? I've got distinct categories, and I've got some overlap between two of my categories. Now, what ways do I know that I can kind of organize information that have some kind of an overlap? Two-way tables are great at showing information, but they don't have an overlap. They are for completely separated categories. What does have a nice overlap is a Venn diagram. Okay? And as my year 11s from my lesson this morning will know, is you've got to read the information really carefully. Don't assume what that information says. Okay? We have 15 members that do not eat fish and do not eat meat. That is people who is outside of my diagram completely. I've got 57 members that eat fish. I've got 41 members that eat meat. Now, with this thing here, got to make sure that we read this really carefully. 57 members eat fish. That is everything within that space, including the middle. And that 41 is the members that eat meat. Again, not including that bit in the middle. And I know that something's got to be going wrong here, because I know that altogether there are 90 people. So I've got 90. Well, if I added all those bits together, I've already got something which does not work. These numbers here are already bigger than 90. Okay? So I know that there should be something in the middle here. And I know that these things will have had that number taken away from it. Okay? This is a particularly awkward problem. Okay? And I know that that must happen because, well, I've already got something that is bigger than 90 just from the numbers that I've got. Okay? In fact, I've got, 98, 103. Which, as we can very kind of see, does not work. Okay, that is why I've needed to put an x in the middle and take that x away from both things. Now in this case, I'm going to have 90 is equal to 57 take away x plus x plus 41 take away x plus 15. Now we know that 90 is going to be equal to this stuff sorted out. Take away x plus x is 0. Take away another x is just minus an x. And now we can see just how many people there should be in that middle. We've got 103, take away x is equal to 90. Well, that just means that minus 13 has got to be equal to minus x, or x equals 13. Okay? And it's about taking that small step. My first small step was to think, okay, I can sort this information into a Venn diagram, but hang on, something's not right here. So let's say that there should be a number in here. How would it affect these numbers? Then, how does that work out with my problem? So we've thought of two things so far. We've thought of starting with a formula, seeing where we can go. And we've thought, let's start with a way of displaying the information and seeing where we can go. Okay? There are other things that we can do as well, such as things that we might use with something that looks a little bit like this. Sometimes you might just have to look at a problem and think, okay, what maths could possibly help me out in this scenario? Okay? Or what bits of information can I fill in that I don't currently have? Okay? So, what I want you to do with this problem, just for a moment, is to just take a look at it. Okay? See what information you can fill in. Okay? See what bits of maths you think you might need to use within this problem. Okay, you might want to pause the video to give yourself time to think. Okay, so if you've had time to have a think about this and think of, what maths could you use, what things are crying out to you, what bits of information have we not got at the moment. Okay, we've got this angle here, which we could work out. Okay, I've been told that this is 35, this is 58, and I can work out that bit in the middle just from doing 180, take 35, take 58, which is 87. Okay, and there's nothing wrong with just taking a diagram that you've been given and adding as much information that you can to it. I haven't even looked at what the rest of the question is asking me. I'm just looking to see what I can fill in. This angle up here, I know is going to be 180, take 58, take 90, which is 32. And I know that this angle over here is going to be 180, take 35, take 90, which is 55. Okay. Now, is there anything else that I can work out from here? Not really. Okay. Now, what is this question even asking? Shows a cross-section of a ski resort in a valley. Okay. The line ABC is horizontal, so that's a flat line. We've got AE and CD are two vertical cliffs. Okay. A ski lift joins D to E, so that dotted line across the middle. Work out the length of the ski lift cable. Give your answer correct to 3 significant figures. Sorry. So, there are some things which are kind of looking at me at the moment. I've got some right angle triangles, and we can think, what maths have we learned that use right angle triangles? Okay, there aren't too many bits of maths that we've looked at in depth that use right angle triangles. One of them is Pythagoras. and the other is trigonometry. Now, for Pythagoras, I would need to know two sides. I don't. I only know the side along the bottom. Okay, which not ideal. What else do we have? We've been given an angle, and normally with trigonometry we are given angles in right-angle triangles. Okay, so it looks like I should be using trigonometry. Okay, and I've got right-angle triangles, so that's thinking of my SOHCAHTOA. Okay, so that's going to be my port of call for this question. Now, what can I figure out with this? I can either figure out my E to B, or my A to E, or my B to D, and D to C. I can work out any of these sides that I've not been given. Okay. What I would need to be careful with is thinking about which sides are going to be most useful for us. Now, this is where a little bit of planning and a little bit of forethought can be quite useful. If I were to work out this side and this side, what would I then be able to work out? What next small step would I be able to take? Well, if I did that, I would be able to work out or know how long and how tall this triangle is. Like this, you could see like here, the one that I've done in red. Okay, like that bit. Okay, because I know how tall A to E is, and I know how tall D to C will be once I've used my trigonometry, and then I will have a length and a height for me to be able to use up here with that red triangle. That would mean that I would be able to use Pythagoras. If I took a different avenue and I said, okay, what if I want to work out these two sides here? I could still do that, but then I would have to use the cosine rule, which is arguably more difficult than using Pythagoras. So in terms of ease, thinking about what can I work out, what would be my next small step, it would make more sense for us to work out AE and DC, so then we know what the two shorter sides of the red triangle at the top would be. Now that might not be so obvious to you that that can happen, but it's about getting started. If you know that you can use trigonometry in a scenario, then work out some sides. Okay? The mark schemes are normally generous enough that if there are two avenues of doing a question, that you will get marks for completing part of that process. So if I decided to work out E to B and B to D, like I was going to use the cosine rule, but didn't know that I needed to use the cosine rule, you will still get marks for those particular bits. Okay, but if you worked out A to E and D to C, and then worked out this bit up here, that would probably get you that little bit further, okay, in terms of working out our end goal, even if we don't know how to get there. So let's summarize a little bit so far. We have looked at three different things that we can do. We can think of what formulas do we know to do with a particular topic or particular thing. We've thought of what ways can we represent information. Can we use a two-way table or a Venn diagram? Can we draw a picture? And what information can I add to my diagram, or what bits of maths do I know that use what I can see in my diagram? That particular method that we were looking at here, by the way, that can be particularly useful if you're working with angles, if you're working with circle theorems, vectors. Okay, these are the kinds of problems where I'd be like, okay, what can I add to my diagram that can possibly make things that little bit easier? Where I think a lot of people struggle with getting started in questions is because they get lost in a lot of the detail and perhaps don't try to take one small step at a time. And remember, we've said that before, take small steps. And I think an ideal question for getting lost in the detail might be something that looks like this. Okay, admittedly, this is going to be a much more difficult question, but where we can pick up marks, we should be able to, or we should look to. Okay, so let's take a look at this. Let's read through the question first. We've got a sketch of a cross-section of a toy. So the sketch just means that it's not accurate. We've got our picture there. And we said that the curve has the equation y equals x squared, take away 14x plus 40, where x and y are measured in centimetres. We're told that BED is a straight line. I need to stop hitting my microphone. And the the ratio of the length B to E and E to D is 3 to 5. We want to work out the area of the triangle ADC. Now, I want you to pause at this moment, and I want you to think, what strategies have we currently looked at already that could be some use here? So, pause, give yourself a minute to think, go back, and then come back to the video. Okay, hopefully you've had your minute to think, having paused and thought about what techniques. I'm talking about an area of a triangle. Now, two ways of doing that. Half base times height. Or, if we're going for the trig route, AB sine C. Now, I don't have any angles involved, so this second route looks a little bit unlikely. Probably not. Okay, probably not. So I'm looking for half base times height. So I'm looking to know how wide is this, and I'm looking to know how tall is this. We're also told that this curve has an equation x squared take away 14x plus 40, which is a quadratic. Okay, now we can also think, what do we know about quadratics? What things can we do with them? Okay, so we've said, like, okay, what can we do with a formula? And with quadratics, we're thinking now, what do we know about quadratics? So we're putting two of our techniques together here. Well, with quadratics, we can factorize them. We can use the formula. And we can complete the square. Now, at this stage, it might be useful for us to think, what do each of these things do? Completing the square can be useful for finding your turning point or your vertex, which is all the way down here. Okay, now that might be fine, but I'm not looking to know the whole height from D down to B. What I'm looking to know is the height from E to D, because I'm looking for the triangle ADC. So completing the square, probably not that one. The quadratic formula tells me solutions, okay, where x is equal to 0. Where y is equal to 0. okay, which would be this point here and this point there, which is, as we can see, the distance for our base of our triangle. So we could use the quadratic formula. That looks pretty good. Now, factorizing does the same thing as using the formula, but normally is useful if we've got a non-calculator scenario. Okay? Factorizing is normally quicker and easier, less likely to make a mistake than using the formula. So, first thing for me, can I factorize that quadratic? Okay, so what I want you to do now is to take 2 minutes. Can you factorize that quadratic? Off you go. Okay, so I'm going to start revealing the answers for this now. So I'm thinking two numbers that multiply together to make 40, that add up to make negative 14. So let me think. 40 to make negative 14. I could use 2 and 20, but that doesn't work. I could use 10 and 4. If they were both negative, that would work. So I'm going to have x take away 4 and x take away 10. Now remember that this is equal to 0 if the brackets are going to be equal to 0. So if x take away 4 is equal to 0, that means that x is equal to 4. And if x take away 10 is equal to 0, that means that x equals 10. So I know that this is at 4 and this is at 10. Okay, so even though we're looking at, getting started, I've now been able to find out the base of my triangle. Okay, I've been able to find out the base of my triangle. Now, where do I go from here? Well, I might need to look back at things here. I've been told this for a reason. Okay, it's very unlikely that you are told a piece of information in an exam that you are not going to use. We've been told this, so we should need to use it. Now, when I was going through this stuff, I said that we didn't need to use completing the square because we weren't looking to use our minimum point. But our minimum point uses that b to e, which we're using in our ratio. So it looks like, actually, I might have to use that. Okay, that might have to be the second part to my problem. Can I work out where my minimum point is going to be, how far down I'm going to have to go, and what this distance here is going to be so that I can use my ratio? Okay. Sometimes a second look at a problem will reveal a different avenue, and that is why we keep on saying, keep checking your paper. If you're spending time at the end of your exam just sat there, then you're wasting your time. Okay? You should spend every minute of your paper, of your exam, doing questions. Okay? Even if it's reattempting something or just doing a little bit extra. If you run out of room, always ask for more paper. Okay? Always ask for more paper if you run out of room. Okay? I would rather you continue it on a different piece of paper than try and squash everything into one space and then make it look a mess. Okay? Your guys' work is normally impeccable. Okay? Don't take that into an exam and then suddenly just throw it out the window because you're trying to cram it all into one space. Okay? If you need more space, ask for some paper. Incidentally, looking to finish this question off, what I'd like you to do now, and this will be the last question of this video, I would look for you now to complete the square, okay, of that equation. So that's your next thing to do. Pause the video and do that. Resume the video when you're done. Okay, so what we're going to do here is to get our completed square, we're going to do x, take away half of this. Now, we're going to have plus 40 on the end, but we're going to have to take off 7 squared, which is 49. So my completed square, which tells me where my minimum point is, where my vertex is going to be this. I know that this point down here is at -9, which makes this distance 9. If this distance in blue is 9, that's the 3 in my ratio. The 5 is going to be 3 times bigger, which makes the height 15. I know that my base is my base is 6 because it goes from 4 to 10. I know that my height is 15, going from E to D. So now I can use my half base times height. Okay. Now these questions were questions that had been stripped of some structure. There was like a part A, a part B, and a part C to all of these questions. Okay. So they were on purpose that little bit more difficult, but it highlights how you can get started with a question. Okay, can you think of a formula that you know to do with a volume or a density or anything like that? Can you think of what you can do with a particular piece of mathematics? Do you know what we can do with quadratics? Do you know a formula for an area of a shape? Can you find a way of representing some of that information that makes it easier to see what is going right or going wrong with your problem? Again, what bits of maths do you know that fit in with a circumstance? Is there anything that you can add to your diagram that hasn't been added already? Okay, those are the kinds of questions that you can ask yourself to get started with that question where you just don't know what to do. Okay. Final point. I said that you should be working through to the very end of your time for every exam that you do. But the most important thing for me is that you should attempt everything. Okay. Make sure that you start the question well. Okay. Even if you don't get to finish it. Attempt everything and give it your best shot. Okay? Hope they all go well, but we'll have some more intervention videos coming up very soon. So make sure you keep your eyes peeled and make sure that you keep on top of it as well. Okay? I will see you in the next one. Bye-bye.